everyone, in this video we will be solving system of equations involving word problems. This is the fourth part. I will put the link of the first, second, and third part in the description box below. Let's take this example right here. A cruise ship travels 120 miles downstream in 5 hours. On a return trip, it took the ship 6 hours. What is the speed of the boat in still water and the speed of the current? In order to solve this kind of problems, we need to follow some steps. The first step is to define variables. So I'm gonna define the variables right here. So I'm just gonna label this as step 1. Okay, so I defined it as x is the speed of the ship in still water and y is the speed of the current. Now, the second step is to set up the system of equation and eliminate one of the variables, then solve for the other variable. So I'm just gonna label that down here, step 2. In order that we can solve this problem right here, we need to remember a formula in science, which is speed times time equals distance. So we're going to create a table in order that we can solve this. Okay, so I've created the table. It's a 3 by 3 table. So we have on this side here, we have downstream and upstream, and then the formula that we have set up on the first part of this step, which is speed times time equals distance. And so we're going to fill this in. Before we fill this in, let's try to differentiate between what a downstream is and what's an upstream, so we can better understand what's going on. Okay, so let's have downstream first. I'm gonna illustrate it up here. Okay, so when we say downstream, if the ship is going to this direction, this is our x, which is the speed of the ship, and then the water is going on the same direction. This is our y. This is what we mean by downstream. Now, if we say upstream, it's the other way around. So in this case, for upstream, the boat is going the other way around on a return trip. So it's going this way, but then the current is going the other way. So this is the x, and this is the y right here. So then we go ahead, and this is. So what are we gonna do is we are going to set up the equation here. So we start with speed. So both the speed of the ship and speed of the current, we're going to set it up here. So we can go ahead and say that for downstream, that would be x plus y. The reason why this is added up, the x and the y, again, we defined it up here. So the reason why we added this, because they're on the same direction. So pretty much like the ship was actually pushed a little bit by the current. So that's why we add them up. Now it says that it took them 5 hours to travel 120 miles. So I'm just gonna go ahead and say the time was 5 hours, and then the distance traveled was 120. So I've filled up the downstream. Now let's have the upstream. So pretty much it took them 6 hours compared to that of 5 hours for downstream, because for upstream, they're going opposite of the current. So pretty much since it's opposite, the current the current was actually making the trip a little harder. So then we can go ahead and say that's x, which is the speed of the ship, minus the speed of the current, which is y, and it took them 6 hours. And again, since this was a return trip, so pretty much the distance for both trips would still be 120. So then we can go ahead and set up our equation here. So I'm just gonna show the work up here. So using this table that we have here, we can set this up as Okay, so I took these values off of the table. Now others are gonna say, like, why did you have to switch the 5? It was after the parentheses, but you're putting it before the parentheses. Now remember, because of commutative property of multiplication, we can do that. So we can put the 5 after the parentheses or before this quantity right here. So it doesn't really matter. So then from here, we can go ahead and distribute the 5 to each of the terms inside the parentheses. Same thing with the 6 that we have here. So once we distribute this, we can come up with an equation which is, that's gonna be 5x plus 5y equals 120. And so that's 6x minus 6y equals 120. So that is after we distribute the 5 to each of the terms and the 6 to each of the terms here. Now, what are we going to do now is we are going to use this equation right here in order that we can eliminate one of the variables, in order we can solve for the other variables. I'm just gonna use that equation down here, so then we can go ahead and rewrite this. Now, what are we gonna do now is we are going to eliminate the x. Again, there's a trick to this. In order that we can eliminate this, we are going to multiply the whole equation with whatever is the first variable here. I multiply it to here. That's 6, and that's a 5. It will be multiplied to the second equation. So that's going to be 5 right there. So then we can go ahead and distribute this. So I'm going to rewrite this. 6 times 5x is, so I'm just going to show the work right here. So 6 times 5x is 30x. That's a plus. 6 times 5y is 30y equals 6 times 120 is 720. And then we do the same thing on the second equation. That's 5 times 6x is 30x minus 5 times 6y is 30y equals 5 times 120 is 600. So then from here, we are going to subtract these two equations. Once we subtract this, that would be 30x minus 30x is 0. So then we are left with 30y minus negative 30y is 60y equals 720 minus 600 is 120. So then we want to solve for y. So then we can divide both sides by 60. Divide this by 60. So then our y is equal to 2. So that's going to be 2 miles per hour. And this is the speed of the current. Again, we defined y as the speed of the current. Now we're ready to move on to the third step. The third step is to plug in the value solved from step 2 to any of the original equations to solve for the other variable. So we can use any of these equations. We can use this. It doesn't really matter. So then we can just pick one of these equations here. So I'm just going to use the first one right here. So we have the equation is 5x plus 5y. So this is, by the way, step 3. So 5x plus 5y equals 120. So then I plug in the y, which is 2. X is equal to 110 divided by 5 is 22, and that is miles per hour. So this represents the speed of the ship in still water. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!